and welcome everyone to today's Synergist product demo webinar, PPI Samplers, a new era of respirable and thoracic particulate sampling. I'm Kay Bechtold, managing editor of the Synergist magazine of AIHA. I'd like to thank everyone for joining us today, and especially SKC for sponsoring this webinar. Today's product demo is scheduled for 30 minutes, and we have a lot to cover, so I'm going to quickly introduce today's speaker, Andy Bragg. Andy Bragg, SKC's Director of Sales, has been in the industrial hygiene instrumentation space for over 30 years and with SKC for the past 8. Andy's knowledge of industrial hygiene and safety instrumentation supports science in the service of people and superior customer and technical support for OEHS professionals. And now I'll turn the presentation over to Andy.
All right, thank you very much, Kay. I hope that everyone can see my screen well now. There we go. Hello, everyone, again, and thanks for joining. In order to not cause distractions, I am going to actually go off of camera for the presentation, and then I will come back on for the Q&A segment at the end. There we go. All right. So thank you all for joining. I'm excited to discuss the PPI with you, kind of the new era of respirable and thoracic particulate sampling. This is meant, of course, to be a product demonstration, but I intend to explain several other aspects of the why and how as it pertains to particulate sampling, and also how the PPI can help be more productive and efficient in your demanding world of respirable and thoracic sampling. Please, as stated earlier, please enter any questions that you have in the meeting chat. We will do our best to get to your questions and get answers for you in the 10-minute Q&A segment at the end. So without further ado, I'm going to dive in and do my best to squeeze about 45 minutes of great information into a 20-minute period. All right. So first, a little information about particle size characteristics. We must first determine the deposition site of the respiratory tract. So as most of you are well aware, smaller particles will tend to deposit deeper into the gas exchange region of the lungs. So we need to break this down into regions of the lungs where we can better identify the particle size, the area of penetration into the lungs, and of course, the hazard that it creates. In accordance with ACGIH, CN, and ISO 7708, the sampling convention for size selective sampling of airborne particulates are very well and simply defined as inhalable particulates that enter through the nose and mouth, thoracic particulates that penetrate as far down as the larynx, and then respirable particulates, which is what we will be focusing mostly on for this demo, which is the fraction of particles that penetrates down to the alveolar region of the lungs. Now on this slide, you will see D50 referenced several times in the slide. So D50 is also referred to as the median particle diameter or median particle size. So basically 50% of the particulates are larger and 50% of the particulates are smaller than the size designated. So for inhalable, which is the fraction that enters the nose and mouth during breathing, the medium particle size is 100 micrometers or microns. Then we have thoracic, which is the subfraction of inhalable particles that penetrates the respiratory tract below the larynx. The median particle size is 10 microns. And then lastly, respirable, the subfraction of inhalable particles that penetrates to the alveolar region of the lungs, and that is 4 microns. So once again, for this product demonstration, we're going to focus primarily on the respirable fraction. So with that being said, I'm going to spend a little time on cyclones. First, for some transparency, I want to say that SKC manufactures 3 different cyclones. So when I demonstrate the strength of the PPI that we're here to talk about as compared to the cyclone. It is not intended to bash anyone else's product. It is just the new era of particle sampling, which of course includes being more favorable to our own cyclones. But we do still manufacture and sell cyclones, and we will for the unforeseeable future. It is very important, regardless of what cyclone you use, to make sure that you understand the different operating specifications for that model. Most importantly, the flow rate is not the same for all cyclones. If you do not sample at the correct flow rate for the specific model, in most cases, your sample will not be valid. So remember, all cyclones are not created equal. Don't wait until after you sample to research the correct flow rate. Most of you probably know the basic principles of operation for the cyclone, but I wanted to include it because the method in which the cyclone works is not that far off from how the PPI works. You have the air and particles coming in and creating a downward cycloning motion, creating centrifugal force. The centrifugal force causes the heavier particles to move outward and lose momentum. They slide down the walls and get collected in a pot at the bottom. The remaining air, clear of the larger particles, moves upward and exits carrying the smaller particles that fall into the respirable fraction. A very simple analogy for this process would be to compare a small sports car to a large tractor trailer going down the highway at 20 miles per hour. At that speed, they can both obviously make most turns, just about any turn necessary. However, if you increase that speed to 75 miles per hour, the larger vehicles will no longer be able to make the tight radius turns like the small sports car could, and they would therefore not make it to their final destination. Now, in the case of particles, that final destination is the 37 millimeter collection filter. Now, this is simply a picture of an actual cyclone with a filter cassette attached. As in the cyclone operation diagram we just talked about, the air enters, creates the cyclone effect to create centrifugal force, dropping the large particles into the grit pot and depositing the respirable fraction of particles onto the filter inside the filter cassette. Now, I hope that everyone is clear on the basic operation and how the dynamics of a cyclone works. But if not, please post your questions in the chat. We'll be happy to answer them as soon as we get to that point. Now we're going to discuss some of the cyclone's issues that we hope to alleviate when designing the PPI. After sampling, the cyclone is removed from the subject and the filter is capped and sent off to a lab. However, you have to be extremely careful not to turn the cyclone upside down, when you go to remove the filter. So whether it is during sampling or in the process of removing the filter cassette, if the cyclone assembly is turned over and the large particles in the grit pot at the bottom get dumped onto your filter, your sample is compromised and most likely invalid. There will be large particles on the filter, and if the lab chooses to still perform the analysis, the results may be very high. This will most likely force you to repeat the sampling event. Also, after the sampling, you must clean the cyclone with soap and water. Otherwise, the particles that stuck to the interior walls of the cyclone will affect your future samples and results because of the inefficiency and the effect on the operation of the cyclone. The aluminum cyclone that we manufacture has a calibration adapter. However, a lot of other cyclones, including 2 of our own models, do not have calibration adapters. So you may have to use the calibration jar to perform your flow settings and flow verifications. This creates a significant area of added difficulty and, more importantly, an area for mistakes or leakage during the flow verification process. we would really, really like to totally alleviate the need for the infamous calibration jar. I will show you how the PPI can point us in the right direction to achieve that. I want to make a quick point too, so I want to take a second here to clarify what I mean by flow verification. I don't want to make any assumptions that may cause confusion for someone. In June of 2023, ASTM stated as part of the ASTM D5337-23 that the process of verifying the flow rate of a pump should not be referred to as calibration and instead should be referred to as flow verification or verifying the flow rate. So hopefully I will not slip up and use the term calibration improperly. It's hard to do after 30 years of habits, and old habits die hard, but it is still part of the name of some of the parts in this presentation, like the calibration adapter, but eventually that will need to change as well. So I just wanted to give some verification of what that means. In the past, we would have called it calibration. If you have ever used a cyclone, here is a recap of some of the common areas of mistakes that you may have encountered. As already mentioned, you must sample at the correct flow rate. That is vital. Make sure that the grip pot is on the cyclone during operation. Many people assume that the bottom opening is the port of entry for all air and particles. It is not. So you cannot remove the grip pot before or during sampling. Depending on the cyclone type, you may have to remove the inlet portion of the filter cassette to attach the middle ring of the cassette to the cyclone. If the person setting it up removes the wrong portion or doesn't remove any portion at all, it can cause the sample to be contaminated or compromised. And again, don't tip or turn over the cyclone during or after the sample until the filter cassette has been removed. And lastly, you must have a very consistent cleaning process after sampling or before using it again. All right, finally, the fun part. The newest option and new era of the respirable and thoracic particle sampling is the parallel particle impactor, or the PPI. Basically, there are three different categories of PPIs shown here. We have the disposable, we have the reusable, and then we show the thoracic PPI. I will go into each of these during this presentation, but again, primarily the disposable respirable version as it compares to the cyclone. Very important to note that on page 16439, the OSHA silica rule accepts any sampling device that conforms to the ISO-SYN convention. We will discuss in a few minutes how the PPI has a collection efficiency more closely patterned to the ISO-SYN convention than cyclones do. The OSHA silica rule also states that there are also personal impactors available for use at flow rates of 2 to 8 liters per minute that have been shown to conform closely with the ISO-SYN convention. So in accordance with the OSHA final rule for silica, the PPI sampler is accepted. This is just a snapshot of that page that I referenced earlier with the areas highlighted. So just in case you wanted to do your own research, hopefully this will save you some time by pointing out the section of the page where it is located on page 16439. Now, more recently, MSHA adopted their new silica rule as well, with enforcement beginning this year. This new rule also recognizes in section 60.12E4 that the mine operator shall use respirable particle size selective samplers that conform to the ISO 7708-1995. Excuse me. On page 28331, it references that as long as the device is designed to meet the characteristics for respirable particle size selective samplers that conform to ISO 7708-1995 standard, mine operators are allowed to use them. This was a very big step for the mining industry because prior to that, cyclone sampling was for the most part the exclusive sampling method. And it was a cyclone that did not have any means of a calibration adapter for flow verification. So it made things extremely difficult and complicated. Now, under the new final rule, the PPI sampler is accepted. And again, if you don't trust me or you want to do your own research, these next two slides are just to highlight where it is stated in the new MSHA silica rule on page 28, 331. So here is the first page where it is listed. And then here is another page. And I'll leave that up there for just a second. All right, so how does the PPI work and why is it better, you may ask? Well, instead of a cyclone effect, the PPI has 4 internal pre-oiled substrates that scrub out larger particles. The section holding these plates is sonically welded into place by SKC and therefore requires no assembly. I will give you more detail about that, about the different colors of PPIs that you see here in just a moment. But as air is pulled into the PPI, the smaller respirable particles that are not scrubbed out and retained on the oiled substrates are collected onto the PVC filter for analysis, just as if it were a standard filter cassette from a cyclone. Same filter, same analysis. So you don't have to worry about finding a new lab or a new analysis method. It is the same analysis process. So here is a phenomenal illustration of how airflow and the principle of operation for the PPI. The air and dust enter in 4 different sized holes, similar to a cyclone. If the particles are too large to make the turn into a second set of holes, they are impacted and retained by the impaction substrate, or oiled substrate, as I called it earlier. These smaller particles, kind of like the Porsche 911 on an exit ramp at 75 miles per hour, can make the turn, enter the second set of holes, and then get collected on the 37 millimeter collection filter. To back up and kind of further elaborate on the design, each PPI sampler contains 4 small impactors in the inlet section of the device. Each impactor features a unique 50% cut point to target a specific 1/4 segment of the isosyn curve, therefore resulting in a precise fit along the entire curve. Again, I know that can be kind of confusing, so if you have any questions on the operation principle, please write them in the chat. Here is proof of the performance and collection efficiency of the 3 different disposable models of the respirable PPI. So all 3 of them, the 2, the 4, and the 8 liter per minute versions, conform closely to the isosyn respirable criteria. There is very minimal oversampling and undersampling. It just can't get any closer than that. So the sampling efficiency is spot on for all these PPIs. To contrast that to some degree, this is a graph that compares the collection efficiency of cyclones versus the PPI. This was data obtained from an internal study at SKC by our aerosol physicist. The yellow dotted line in the graph represents the respirable convention. Cyclones are represented by the red and blue lines, and the PPI is shown with the green lines. According to this graph, most available cyclones oversample it with particles smaller than 4 microns, and then they undersample when you're talking about particles larger than 4 micron as compared to the respirable convention. So you can see that in this area and this area as far as the over and under sampling. All right, more fun facts here. So other than the collection efficiency and performance benefits, a calibration adapter makes it very easy to perform a flow setting and also flow verification on the PPI in the pump. There is no tipping hazard with the PPI while sampling or after sampling is complete. You can invert it without compromising your sample. And I am sure if you've used cyclones for any amount of time, you can imagine the time savings and cost benefits that this creates. There is no cleaning necessary for the disposable PPIs. They are a one-time use. Once your sampling event is complete and you have performed your post-verification of airflow, disconnect the device from the subject and from the pump, then seal the sample and send it to a lab. And I'll give you a little bit more detail on sealing the sample momentarily. You can purchase these through the PPI through us directly or our distributor partners, or even through most accredited labs. We truly had all of your productivity and efficiency in mind with this product design. For the disposable models, you can see here that we offer the 8 liter per minute, 4 liter per minute, and 2 liter per minute models for respirable sampling. And we also offer the thoracic sampler at 2 liters per minute. All of the respirable samplers are offered empty, meaning we ship them to you without a filter for those that may want to load them themselves. We also offer it preloaded with a standard PVC or even an MCE filter, depending on your application, or pre-weighed with PVC filters. Now, the thoracic PPI is only offered with the MCE filter. We do offer a reusable version of the PPI, and it is about the same size, but it's a little bit heavier because it is machined aluminum. It requires a little more maintenance due to the cleaning after each use and the periodic replacement of the oiled substrates. However, it does create a great option for someone doing research or someone that is doing sampling that has possibly an on-site lab and does repeat sampling where they have the ability and the environment that they can take it apart, clean it, and reuse it. So here is the beauty of the PPI sampler all wrapped up kind of into one slide. We have the easier setup, flow setting, and flow verification due to a simple calibration adapter and a one-piece sampler that has no assembly required. You have more productivity and lower cost due to the elimination of the tipping hazard, meaning that more efficient sampling due to less repeat sampling. You have easy notation because we supply you with more labels than you will need for each PPI, and we do that in case there is a mistake. You will have extra labels that you can use. So you can note details for your sampling event purposes prior to sampling and also for the lab analysis benefit. You simply remove the rubber cap from the outlet port and connect that port to the tubing from the pump. Once you're done with your sampling, you reapply the black cap to the outlet port and apply the sticker we provide you to cover the inlet ports or the inlet portion of the impactors to maintain the integrity of the sample for shipment off to a lab or for shipment analysis. And as important as all of those above, it is also much lighter, less obtrusive, and less cumbersome for the subject wearing the device. Therefore, you will see more cooperative sampling experiences and a better representation of real-world exposures since they can perform their task as they normally do without worrying about bending over too far or turning the cyclone upside down. So I hope that this has given you a good look into the features and benefits of the PPI as it pertains to your application. If there is something I didn't answer for you, please take the time now to enter it into the chat quickly as we are about to go into the Q&A segment. I have asked a couple of very qualified panelists to help answer your questions. Saulius Trachimus is not only an aerosol physicist, and he's not only our product development and engineering team leader, he also is the inventor and subject matter expert on the PPI. So I'm very grateful that he is here to answer any of your questions. Dusty Ott is our corporate CIH, who has a lot of experience in practical industrial hygiene sampling in the mining industry and as a civilian in the military and other industrial applications as well. And yes, his given name actually is Dusty. So go figure. All right, I think that we are ready to take some questions.
Okay, great. Thanks, Andy. It looks like we have about 4 or 5 minutes left for questions, so I'll jump right in. The first one is, doesn't loading the filters yourself potentially add to the SAE?
Dusty, is that a good question for you?
I was reading that and I'm like, I don't actually know the answer to that question. That would be a really good question for one of our lab partners of what influences the SAE of the given samplers. Maybe Solage knows a little bit more of that than I do.
Oh, sorry. I guess, like with regular cassettes, if you know how to handle those kind of things, they should be fine. But
I will say this, that most of the PPIs that we ship out do have loaded filters or pre-weighed filters in them. We don't ship near as many empty PPIs as we did when they first came available.
Okay, great. The next question I have there been studies conducted on the collection efficiency in wet environments?
Wow, that is a popular question. I think Dusty and Solis have both probably been asked that question. Dusty, you want to address that from a CIH standpoint?
Yeah, so the question that we've had a lot is sampling with both PPIs and cyclones in wet environments where water is actively like being used for the cutting material, and that water is being then sprayed onto the person being sampled and into the PPI or into the cyclone. And what we found is when that happens is there's silica particles that are inside of the water from the cutting that are suspended in the water and then get trapped inside of the PPI or filter from a cyclone, analyzed from the lab, and they have extremely high results. That's not because there's any airborne particulates, just because there was water that was forced into that cassette. And so there's not really a good way to sample in those types of wet environments. I talked to a lady yesterday about consulting the table 1 from OSHA about when and where sampling is required based on engineering controls of those types of saws. But I mean, Solius, is there anything else you want to add to, spraying wet environments with PPIs or cyclones?
in general, aerosol or kind of, it's like solid or liquid particulate, so there should be no difference. However, when water is being used, to during cutting or some different operations, there is a lot of large, stuff generator, and it may fly to inlet of any sampler, and this is where all this kind of problem is happening. And one may say that PPI maybe is more susceptible to large particulate because it's facing outwards of the person, but you would think that that is more representative because those large particulates may fly in your nose and your mouth too. So
You know it's bad when you take the cassette and you dump it out and water is coming out of it. That's kind of a telltale sign.
that is definitely
Yeah.
not good.
Okay, thanks. I think we've got time for just one more question. Are PPI samplers for the respirable fraction recommended for measuring worker exposure to welding fumes, specifically for addressing the ACGH respirable TLV for manganese?
Why not? They're collecting respirable fraction. There should be no any issues with that.
Mhm.
And if there are any recommendations, I really don't know, but Dusty.
Yeah, we sell plenty of the PPIs with MCE filters specifically for welding respirable particles. So yeah.
Okay, might be able to squeeze in this one too. Is there an expiration date on the PPI?
Yeah, that's a good one. We have the expiration date set at 18 months from manufacturing. And Solis, do you want to elaborate on why we set that period of time?
Because those collection substrates are oiled with silicone oil, and that oil, in time may dry or something may happen. Though we are confident after 18 months that collection substrate is still going to work well, and it's difficult to know how long it's going to last, so it's a bit kind of precautionary expiration date, but you know.
Okay, great. Unfortunately, that's all the time we have for today. Just wanted to let everyone know that we'll be sharing all questions from today's event with SKC. So if we didn't get to your question, please know that we will pass it along. My thanks to Andy Bragg for his presentation, to SKC for sponsoring today's product demo webinar, and to all of our participants. Please visit aiha.webvent.tv to learn more about 3 more upcoming Synergist webinar events. Thanks to everyone again, and have a great day.
Thank you all.
Thank you.
Cool. Bye-bye.